We're having a funeral for Optane. More of a wake, really. And it's party time because Optane's on sale. This is not a drill. Oh my gosh. I'm going to show you some cool stuff you can do with the Optane you can get for really cheap. Okay, first of all, this video is mainly about ZFS and like home server stuff you can do with your Optane. I want to show you a bunch of different options. But mainly we're going to talk about ZFS and how it can really speed up ZFS if you have a home server that's based on ZFS and you use Optane for caching. Now, you can use Optane for other RAID solutions, Unraid, anything like that. They have their own caching systems. But for ZFS, it's the metadata special device that I want to cover. You could say that I'm a fan of Optane. I've always been a fan of Optane. There's a lot of hard-won Optane from way back in the day on my desk. Look at all this, these drives. The P4800X, this is the enterprise version. This is 750 gigs on a PCIe card or a U.2, these 2.5-inch drives. You can use these in your desktop computer. It doesn't matter if you don't have a slot for these. You can use this adapter cable, and look, this just plugs into an M.2 slot. It's low profile. I've even put this in the Cooler Master NR200, the small form factor case with the thick 2.5-inch PCIe device. Yeah, P5800X Optane. Now the second gen Optanes, they're not on fire sale, but the first gen are. Look at this madness. I have the 58 gig, I've got the 112 gig, and I've also got a bunch of the H20s. So the H20 is a special device, we'll come back to it. It's hybrid Flash and Optane, and it's just a little bit of a special use case. I also got some of these 16 gig Optanes because these were like 10 bucks each. I got these in a different sale. These are, I can't recommend these. They're just too slow. There's not a lot you can do with the individual 16 and 32 gig Optane M.2 devices. I'm sorry, it's just, don't recommend it. But that's okay because there is a crap load of stuff on sale. These 58 and 112 gig Optane in an M.2 form factor, these are what's on sale, and this is the awesome spot. This is actually, well, at the time that I'm doing this video, there's a Newegg limit. It was limit 3 per person, and I wrote in a bunch of complaints that was like, no, I need to be able to buy 4 and 8 of these at a time, because if you're a ZFS aficionado or you like doing stuff with ZFS, you really should buy 4 or 8 of these if you really want to dramatically speed up your array with the metadata special device. But I'm getting there, You got adapters like this one. This is 2 U.2 into 8 PCIe lanes. This is a special PCI Express 4.0 compatible card. These are really hard to find. You buy these on AliExpress or eBay and they say they're PCIe 4 compatible, but they're not actually PCIe 4 compatible. A lot of the time you have to use these in a slot on the motherboard that's physically closer to the CPU. The ones at the lower part of the motherboard won't work because these cards are a little sketchy, but this is a great way to get PCI Express 4 connectivity for your second gen Optane. Fortunately, all of the Optane on fire sale is PCI Express 3, so you're not going to have any of those problems. The 900 and 905p, now the 905p is what's on sale. It's essentially the same as our P4800X series here. I've got a bunch of the 375 gig P4800X. I like those a little better than the 900 and the 905 for a couple of reasons, but they're still a really good buy. This is the reserver from Seed Studio. That plus this wee little M.2. This is a Coral.ai tensor processing unit. This is the one that's got 2 on it. This in there with 2 mechanical 20 terabyte hard drives plus an Optane for storage. The Optane is never going to wear out. That's what we're buying here. That's what makes Optane better than NAND for all these applications, is that you're writing to it a lot and you never have to worry about the right part of it wearing out. I mean, it can break, there's other stuff that can go wrong with it, but in terms of exhausting the right capabilities of the device, it's probably not going to happen to you for any kind of halfway reasonable workload and about 7 unreasonable ones. There are also these adapter cards. You can put 4 M.2 on a single PCIe. Why would you ever want to do that? So with ZFS, you have to understand when you've got a mechanical array, your data is broken up across a whole bunch of hard drives. It's like RAID, but ZFS is a little more advanced than RAID. This also kind of applies to LVM because you can use caching devices on Linux. So if you're gold star Linux operator and you know about LVM's caching and all this other kind of stuff, you can set the same kind of stuff up there too. But ZFS makes this really easy. It makes this really easy to do this on TrueNAS, anything else. Your data is stored on a mechanical hard drive. For ZFS to figure out where your files are when you go to ask for a movie, it has to look up the metadata of, okay, where are all the blocks of data? And for big files, you know, there can be 1 or 2 levels of indirection, meaning that it's got to do a lookup and then another lookup. And then by the time it does the third lookup, it's got the giant list of all of the blocks of data for the file so that it can go read your movie file. Mechanical hard drives can do a single I/O operation at a time because it's only got the one read-write head to move back and forth. M.2 storage devices have queues, and they can operate massively in parallel. When I'm talking about NAND flash, you know, a normal M.2, not Optane, those have lots of queues to operate in parallel. When you look at Crystal Diskmark and you look at benchmarks around queue depth 1, and it just does queue depth 1 benchmarks, you know, your modern, very expensive PCI Express 4 or even now 5 SSD can usually only manage on the order of 50 to 100 megabytes per second in terms of queue depth 1 I/O, meaning that the computer asks for one block of data and then it randomly selects another block of data as soon as that one completes. And it's that whole round trip time. And so because it's only doing one thing at a time, it tends to be very slow, or at least hundreds of megabytes per second instead of thousands of megabytes per second when you've got lots of operations in parallel. And to be sure, ZFS can request multiple blocks at once as well. It's not necessarily just queue depth 1, but the better the performance of queue depth 1, the more snappy and responsive the whole system feels, whether you're running a desktop computer, ZFS, whatever. So what you can do with ZFS is you can tell it to store all of the metadata, the lookup, the indirection for all the blocks on a different device, on a special VDEV. Now, that device still has to have redundancy, meaning that you need at least a mirror, at least 2 of these. And if your data is really important, you may want a 3-way mirror. I myself rock a striped mirror or a dual striped mirror, meaning that I have 4 or 8 M.2 devices that are storing the metadata in a redundant way available on the storage array. And then the data itself is actually stored on mechanical hard drives. What this does is it dramatically speeds up any kind of search or lookup or reference operation for seeking the data. The mechanical hard drives, the poor little plucky mechanical hard drives where they only have the one read-write head and they can only do one I/O operation at a time, having all of the metadata on different devices immediately takes away all of those metadata I/O operations from the mechanical drives. So it seems like the entire system is way faster because you're not doing those lookups over there. So that's why it can be useful to use a device like this to shove into a PCI Express by 16 slot and get 4 PCI Express slots. This one's from Gigabyte. You can order these online. Everybody under the sun makes these. These are only like 20 bucks. You do have to have a BIOS option that will let you turn on bifurcation so you can run the slot in an X4, 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 X4 mode. There are other devices available on the market, sometimes devices from Liquid, HP Enterprise, and other storage providers come up on eBay, and they're cards that have multiple physical M.2 slots, but also have a PLX bridge, a PCIe bridge, or something like that on them. Not a RAID controller. There's 1 or 2 M.2 RAID controllers out there. Don't use those. That's not good with ZFS. But those controllers is a true PCIe bridge. So you could actually have 8 PCIe lanes going into 4 M.2 devices, and that works fine. Or there's even a couple out there that are 8 M.2 devices into an X16 slot, and that's really awesome if you can get your hands on those. But those very rarely come up on eBay, so you got to set up some watchwords and sort of know what you're looking for. But those PLX bridges, retail price, very, very expensive. So you're only going to get those on the secondary market used, maybe on AliExpress, something like that. So for our Optane test rig, just so you understand, this is what I set up. It's a very, very trivial example. I'm not even using any of our petabyte of hard drives or anything like that, but I am using the 45 drives chassis and some more chassis below that because it makes it easy to set up many drive tests. But I was very surprised by what I found, so I set up a smaller test with just 3 drives, 3 mechanical drives. So this chassis from 45 drives actually has 2 different 3-drive ZFS pools. If we run ZFS status, we can see both of those pools. I'm going to run a very simple command that basically just times how long it takes to scan the whole directory. One of those is 3 mechanical hard drives, and the other is 3 mechanical hard drives with our 4-way, our striped mirror for our ZFS metadata special device. That's what we're looking at when we do the ZFS status here. We can see that we've got a special VDEV, and that the special VDEV has our metadata on it, and those are Optane devices. The command that I'm using is time find dot pipe WC. So this is going to find dot and tell us how many lines find a dot return, so you can see it's approximately the same number of things. This is the same directory structure between these two ZFS pools. Same files, same everything. The pools were set up exactly the same way. The drives are set up exactly the same way. And then we run the same command again on our other ZFS pool that has the metadata special device. 177,365 for the number of files that it had to scan in 2 minutes and 26 seconds. All right, let's switch arrays. I'm just running the same exact command one more time. Just scan everything. The same 177,365, but look at that. 30 seconds, not 2 minutes and change. That's the power of the metadata special device. You'll be able to find whatever it is you need on your array a lot more quickly. You'll be able to scan directories, find internal stuff. You can even use the metadata special device to store very small files. So if you wanted to go nuts and add a lot of high endurance Optane in the hundreds of gigabytes range and use those as a metadata special device, but also store your small files on those as well, you know, files that are less than your record size, you could do that. That's an option with ZFS, but this is dramatically faster. Now you may be thinking, why can't I use NAND storage for this? Well, if your data doesn't change a lot, you probably could, but Optane doesn't really wear out. It has orders of magnitude better wear capabilities, and its QDepth1 performance is always better than NAND devices, meaning that the latency of servicing that initial QDepth1 device is going to be lower, and as a result of that, whenever it's got to do a bunch of QDepth1 IOs, it's going to be in the hundreds of megabytes per second, as opposed to, you know, 50 or maybe 100 for the highest end devices. Now Optane also have queues, so they can do a lot of things in parallel as well. It's not just the single performance. You get the benefit of both things happening there. So that's really exciting. And that's why you might want to buy 4 or 8, 118 or 58 gig Optane. Now, I really just recommend that the 118 gig Optane, the 58 gig Optane, I also did some testing with. Those are only 2 PCI Express lanes. You could use those 2-lane PCIe devices with something like this, and it'll, you know, not use some of the PCIe lanes. This works fine with those devices, but it's better if you can do the PLX bridge, because those 2 PCIe lanes, they're not going to be insanely fast in terms of raw throughput, but they are still going to be low latency, and they are still going to have really great performance in low queue depth scenarios, you know, getting 1 or 2 IO operations going per second. Now, if you want to rock Optane for your desktop operating system, one of the reasons why people didn't do that is because, well, I mean, look, these are 280 gig. So I'm working on another video, you know, just using these with Windows. You can use them with Primo Cache, so you can get, you know, a Black Friday sale 4 terabyte NAND flash device. Those aren't going to have good performance in terms of QDepth1 or anything else. I mean, the transfer rate might look good, but you can use Primo Cache and one of these smaller Optane, even the 118 gig Optane, to accelerate and cache frequently used information on that device. That works great. The other problem that Optane had was your operating system will do that too with any extra memory that you have. So if you have a system that's rocking 64 or 128 gigabytes of memory, that'll perform really well, especially the second time you go to load a game. With Optane, as we see on our ZFS array, on a fresh reboot, well, it didn't have to cache anything. It was already there, stored forever on the device. There wasn't anything that had to load. And it kind of works like that with Primo Cache. If Primo Cache can cache it on Optane, then when you go to start a game, it's going to be fast because you launched the game the last time you rebooted. It doesn't have to be cached into memory. It can be good, but the cost benefit, well, the market decided that the cost was a little too high and complication was a little too low. But for these edge use cases like ZFS, it's still really good because the devices won't wear out, they are insanely low latency, and they work really well. Now, I haven't talked about the other ZFS devices you can use, the L2 ARC and the S-Log, separate log device. Optane is a separate log device. It tends to work really well, although you're going to want a bigger one. So I would recommend like the 280 gig device or the 905 for a separate log, and the reason is because this is a single device that is very, very fast. You can use the 118 gig Optane. Those are 4 PCI Express lanes. Their write speed is okay. It's not fabulous, but it's okay. And then your write S-Log will be 118 gigabytes, which is probably enough for between, 10 and 30 seconds of in-flight data to be cached on that device. You can also use Optane as a separate log device. Again, larger devices like 280 gig or 375 gig or whatever you can get generally will be better because that cache will survive a reboot, and that is like a read cache, and it's caching not just the metadata but also the actual data. For me, from my experience with ZFS, I'd much rather have the metadata special device and use my Optane for that. But if you want to go Optane crazy, you could have an L2 ARC, and that doesn't need to be redundant, that is your cache, plus your metadata special device as a striped mirror on something like this, or even a RAID Z1, or you can go more than 4 devices, you can go 8, that would be fine. But all of this is on fire sale, and I'm kind of in hoarder mode to hoard these things up. And I really wanted to share some ideas about how you can use the 58 and 118 gig Optane devices, because they're too small to boot from and use as an operating system. You wouldn't want to use it as a primary drive, because even though the latency is very low, everything else is not as fast as modern NAND. It's good low latency, good QDEP1 performance, but they're outclassed in other performance by even middle of the road NAND flash drives. So you really, to get the most out of them, you use them in conjunction with something else. So when we're talking about something like a laptop, if you could theoretically put something together like that for a laptop, it might work really well. That's exactly what the H20 is. It has 2 PCIe lanes for your NAND flash device and 2 PCIe lanes for some measure of Optane storage. Now the 512 gigabyte or the 1 terabyte versions of the H20, they would be what I would recommend. I actually run an H20 in my personal laptop because I like the very low latency of that performance. I did a review of that, and you can basically launch a whole bunch of applications simultaneously. Now 32 gigabytes is not really enough, in my opinion, for modern gaming scenarios and gaming workloads. But for using Git with a bunch of small files and Visual Studio Code and switching back and forth between the same half a dozen productivity applications constantly, the 32 gig Optane as cache works really well. And it makes the whole laptop feel snappier because it can launch a whole bunch of things at once. I showed that in the video. It still works really well. You can now buy the H20 devices and use that. The rub is you can only use that with Intel rapid storage technology, which means Intel laptops. It's not going to work on an AMD laptop. It's not going to work properly with AMD RAID. You've got basically no option for any of that. You're relegated to Intel RST. For me personally, I like it, and I think it's worth it, which is why I run an H20 in my laptop. But Optane and special use cases and a eulogy and buy this stuff while it's still on sale, yeah, just a PSA to let you know that that's there and I'm doing this and some fun stuff. So if you want to see some benchmarks or some real world, or you want to see me shove a 750 gig P4800X in the NR200 again, let's do it. All right, I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums.